In this video, we are going to look at the relationship between pressure and volume. When two variables have a direct relationship, they both either increase or decrease together. So they follow the same trend. When two variables have an indirect or inverse relationship, they follow opposite trends. What we're going to look at here is the inverse relationship between the pressure and volume of a gas, which is known as Boyle's law. Boyle's law states that for a fixed mass of an ideal gas at a constant temperature, the volume of the gas is inversely proportional to the applied pressure. If the pressure doubles, for example, the volume decreases by 1/2. This law can be stated mathematically in the following equation: P1 V1 equals P2 V2, where P1 and V1 are the initial pressure and volume, and P2 and V2 are the final pressure and volume. The pressure times the volume is a constant, provided that the temperature and the amount of the gas remains the same. So Boyle's law can be stated again as P1 V1 equals P2 times V2. Temperature and the amount of gas is constant. Under normal resting conditions, we breathe about 12 times per minute, each time inhaling and exhaling about 500 mils of air. When we inhale, we lower the diaphragm or raise the rib cage, either of which increases the volume of the chest cavity. In accord with Boyle's law, as the volume of the chest cavity increases, the pressure within it decreases and becomes lower than the outside pressure. As a result, air flows from the higher pressure area outside the body into the lungs. While the difference in these two pressures is only about 3 millimeters of mercury, it is enough to cause airflow into the lungs. In exhaling, we reverse the process. We raise the diaphragm or lower the rib cage. The resulting decrease in volume increases the pressure inside the chest cavity, causing air to flow out of the lungs. So let's do some calculations using Boyle's law. Freon 12 was used in refrigeration systems. What is the new volume of an 8-liter sample of Freon gas initially at 550 millimeters of mercury after its pressure is changed to 2,200 millimeters of mercury at constant temperature and amount? So we write what's given. We have our P1, our V1, our P2. We know that temperature and amount do not change. We need to find V2. So we're just going to plug into our equation P1 V1 equals P2 V2. Now you do need to know the gas laws for your exams. I will not provide them for you on a formula sheet. So when we substitute in, we can see that the volume of a gas changes to 2 liters. Again, this makes sense because we have increased the pressure, so therefore we should decrease the volume. Here's our learning check. A sample of oxygen gas has a volume of 12 liters at 600 millimeters of mercury. What is the new pressure when the volume changes to 36 liters at a constant temperature and amount? Before you set up the calculation, realize that we are increasing the volume, so that means that we have to decrease the pressure. The pressure needs to be less than 600 millimeters of mercury. So right off the bat, we can get rid of choice C. So our calculation is P1 V1 equals P2 V2, so that we have 600 millimeters of mercury times it by 12 liters equals P2 times 36 liters. And our answer is 200 millimeters of mercury. For a cylinder containing helium gas, indicate whether cylinder A or cylinder B represents the new volume for the following changes. So again, we're going to keep the amount and the temperature constant. When the pressure decreases, that means we have an increase in volume. So number 1 should be choice B. When the pressure increases, we should have a decrease in volume, and that is represented by picture A. If a sample of helium gas has a volume of 120 mils and the pressure of 850 millimeters of mercury, what is the new volume if the pressure is changed to 425 millimeters of mercury at a constant temperature and amount? So now we are decreasing the pressure, so our answer should have an increase in volume. So without even needing to do a calculation, we can get rid of choice A and choice B and find that choice C is the answer because it's the only one that shows an increase in volume. But here is our table with our givens and what we need to determine. We need to use Boyle's law, the P1V1 equals P2V2. When you substitute in, you can see that you get an answer of 240 mils. It's very important with this simple law that we use logic and we determine if the pressure is increasing, then the volume decreases. If the pressure is decreasing, then the volume increases. That indirect inverse relationship. A sample of helium gas in a balloon has a volume of 6.4 liters at a pressure of 0.7 atm. At 1.4 atm is the new volume represented by A, B, or C. So here we are doubling the pressure. So we should be reducing the volume by 1/2. So here's our initial volume. And then so the answer is going to be choice A. Again, you don't have to do the calculation out. What you have to recognize here is that we double the pressure so that we have to half the volume.